Hello and welcome to this lecture on garbage collection. When Java was introduced, they studied a lot of drawbacks of C programming language, one of which is handling of memory. Responsibility of a developer to free the allocated memory often leads to two major problems. Number one is called memory leak. Now this happens when a developer allocates memory and over a course of time, so the developer will not allocate or deallocate the memory. And this shrinks the memory logically and eventually your program will run out of memory. So we call it a memory leak. There is another problem called as dangling pointers. It usually happens when a function creates pointers and allocates memory, and then you come out of the function, the allocated memory is removed. And the pointer comes back where we would think that the pointer is still pointing to the memory, but inside the function that would have removed. Now generally this happens when you're working with arrays or dynamically created memories. Now these two problems are eliminated by Java with the approach of garbage collection. So at the end of this video, you should be able to understand what is mark and sweep mechanisms, define generations in Java. These are some memory parts so that you will understand. Describe what is called as generational GC or garbage collection. So let's begin by understanding the hotspot JVM's architecture. Now as you can see, at the runtime data access, there is heap and there is method area where there is a function call stack and there are local variables and all those stuff. And then there is a garbage collector at the execution engine. There is a just-in-time compiler that compiles the code on the fly. So primarily we are focused on the heap and the garbage collector. Now note that even though garbage collector's name says it is supposed to collect the garbage, now this is the component of Java that creates objects too. So it will also keep track of these memory areas. Now let's begin understanding the basics. Garbage collection is a process in which Java recollects all the space occupied by dead or abandoned objects. Meaning you had a reference, you make it point to an object, now you make the same reference point to another object, or you say the object reference equals to null. The previously allocated object that is abandoned or not going to be reachable, so you can't access that. So they are unreachable, abandoned or dead object for us. In general, garbage collector is responsible for allocating memory for new objects, which is generally untold of, ensuring that any referenced or live objects remain in the memory so that we don't run into problems, recovering the memory that was used by objects that are no longer reachable or so-called dead objects. Now here is a picture representing before marking and after marking. Now what happens here is that in the memory there is a lot of objects and objects get allotted again and again and again, and eventually you will run out of space. A garbage collector will run a process called as marking. Now in the marking you have a green colored live objects, they are all reachable, and the red colored ones are unreachable objects. So the garbage collector first performs this marking process. Now each object the garbage collector meets is marked as being used or not being used. So they will not be deleted. Okay, so there is a process called sweeping. At that point in time, the marked objects, the live objects will be retained. The second process is called sweeping. Now in this sweeping, all the objects that are unreachable or unused or abandoned, they will be zero filled, and location, the starting point of each of these dead objects or the cleaned area, they are noted down. So in the picture, now sweeping process will have to remember addresses of three different areas. So the sweeping stage is where deletion of objects take place, and an older way of doing this is by making sure that each pointer is noted. Now there is another process that was introduced later called compacting, where during the sweep, after the sweep is over, you move all the live objects together. So now it has to remember only one pointer from where new allocations can take place. And this way the object allocation can be much faster. So those are mark, sweep and compact. Now there are some problems in this particular model, and this model is also called as non-generational GC because later they introduced something called generational GC. So the problems in the non-generational GC are increased objects, reduced performance, ignores typical object behaviors. So these are all some of the common problems encountered. Now generational GC improves on this particular features. Here the entire memory is divided into various generations. Now as you can see, there is a permanent generation, there is a tenured generation, which is also known as old generation, there is a survivor space and there is Eden. Now the survivor space, two of them together with Eden is known as young generation. Now here is where newer objects tend to live. The old generation is meant for the objects that are quite old, and let's come to the stage where we understand how an object is treated as an old object. Now occasionally you will find an object that is too big to be created in the Eden. So that will be directly created in the tenured location. So Hotspot uses this generational garbage collector for improved performance. So this works on each of these spaces. Let's consider the memory space as if divided into three sections. Younger generation for new and young objects. When you say new and young objects, a newborn object or probably an object that passed a couple of garbage collections, they are still young, and generally smaller objects. Now the younger generation is divided into three parts. Eden, there is a survivor space, we call it as from survivor space, and there is another space or a survivor space called to survivor space. This from and to periodically interchange, so we'll come to that in a minute. So tenured or old generation, this is for older objects. Now what do you mean by older objects? If an object survives multiple garbage collection process, that means they tend to live longer. So after certain times, like for example, if it has survived more than 8 or 9 garbage collections, then they will be moved as an old object and they tend to live much longer period in time. There is a third one called as a permanent generation. General idea is that you store, or JVM stores all the classes, static variables and many metadata information in this particular location. Generally permanent generations can't grow. Now because of this, over a period of time, if you have a lot of anonymous classes being loaded, you might encounter into something called permgen exception, and you will get an out of memory error and your program will collapse. Now let's look at younger generation. Now GC or garbage collections occur relatively frequently. That means the garbage collection in this generation is faster, but it's a smaller in terms of time. So GCs are fast and efficient because young generation space is usually small compared to that of the old generation. And they likely contain a lot of short-lived or dead objects, so the amount of real objects that it has to collect is less. Objects that survive some number of young generation collections, then they will be moved on to the old generation. We call it as promotion. So let's look at old generation. Typically they are larger compared to that of younger generation. And because the amount of garbage collection cycles takes place is very less, but when it happens, it has to sweep a big area, and we call it as a major garbage collection too. Now its occupancy is slow because out of hundreds of objects that get created again and again, only few of them survive garbage collections multiple times, and they will be moved slowly to the larger or older generation. So the number of objects in the old generation generally is less. Now garbage collections are infrequent here, but when it happens, it takes more time because it has to clean up a bigger area. So GCs in old generation should be minimized. Now, here is an example or a pictorial representation where objects are allocated in the younger generation, but they will be promoted over a period of time to older generation. And pictorially we say that the old generation is bigger than the younger generation. But allocation always happens in the younger generation, especially in Eden. Now, here is a pictorial representation of allocation in the younger generation. So we have Eden and lots of objects are created, and the last one being allocated over here will trigger the process of garbage collection, especially what's called as a minor garbage collection, because here is a filled memory, and now we need to consider how many objects are live and objects are dead. And this is done with what's called as mark and sweep. And when the marking has happened, you can see that lot of live objects are found. They all will be moved to SS0, or what is called as the 2 survivor space. And they are also given an age of 1 because first time they survived a garbage collection life cycle. The next step would be to clean up that area, and when you clean that area, so you have unreferenced objects, they all will be swept and it's clean now. Again, the program will be resumed because until now, stop the world garbage collection was going on. Now it is finished, the program execution is resumed. And when the program execution begins, there is a set of new objects allocated, and once the memory in the Eden is filled with lot of objects, now we come to a second garbage collection. At this time, when the mark and sweep happens, it does not happen only in Eden but also in the survivor space 0, and this time SS0 is considered as from survivor space and SS1 is considered as to survivor space. And as you can see, the object from Eden are moved with an age of 1, and object from survivor space are moved as age 2. So this happens, and then there is a sweeping, and at the time of sweeping, it's going to sweep the Eden and the SS0 or from survivor space. Now once this is done, now again program is resumed, and over a period of time new allocation takes place, again a garbage collection is run, and this time from the Eden it's going to be moved to the 2 survivor space with an age of 1, and there are already some objects that existed in the survivor space 1, they will be moved with an age of 3. So you can see that some objects are being increased in their ages, and this continues for some time, and over a period of time you will see that there are some objects which survive more than 8 or 8, 9, something that your JVM can be configured with. So the age 8 in this figure indicates that they are ready to be qualified as an old object. Now you can see that the object from the survivor space will be moved on to the tenured or old generation, and the rest of the places it continues as it is. Now this is the concept of generational GC. So the objects are allocated in Eden, they're going to use the survivor space for swapping, and eventually they get moved or tenured to the old generation. So generational GC, let's summarize. Process repeats until each minor GC is executed. Now when objects in the young generation reach an age threshold, in our example it was 8, they are moved or tenured to the old generation space. Some points to remember: young generation, that is divided into Eden, survivor space and objects age here. That means that every time an object survives a garbage collection, it will be incremented with its age. When its age is reached some threshold, it will be moved to a older generation. We have minor GC, which are always stop the world events, which means your program execution stops so that there is no new memory allocation going on when the young generation is being cleaned. Now there are some more points. Old generation means they contain objects that have reached the minor GC age threshold. In our example it was 8, it could be 9 or 10 depending on how it's being configured. Major GC happens slowly, infrequently, but it takes a lot of time to clean because it has to cover a wide area. Now there anyway the objects get stored slowly, so the filling of the old generation takes a lot of amount of time. Permanent generation contains metadata required by the JVM, something like classes and static variables, methods, they all sit here. Now intern strings are also kept here because it's a pool and static data. Let's quickly summarize what we learned in the garbage collection. Marking is a process to identify all reachable or live objects. Even though we say it is a garbage collection, it does not collect the garbage, it collects the live objects. Sweeping is another process that cleans the memory by zero filling, and then there will be a compacting where all the live objects will be moved together. Now since there were some problems in the traditional mark sweep compact, generational GC was introduced where generations are nothing but parts of the memory where objects of different ages are kept. There is a young memory, there is an old and permanent. A new object is always created in the young generation, specifically in Eden.